Here we go. Today we are continuing for our third day of identities. I'm not adding anything new today. We're going to practice some things and see how we're doing overall. Okay, we kind of get an idea of whether we're doing well or not, hopefully by the end of the day. Okay, the one thing I can tell you is there are ways of solving problems where you just kind of hammer through them. Okay, like this problem on the board. You could hammer your way through it and do a whole lot of steps. Okay, 20, 30 steps by the time you get done. Or sometimes you can find a little trick or a twist that could make it a lot easier. Okay, for example, that choose your own adventure assignment last night. Okay, the 115-point problem, everyone's trying to do it. The one in my notes, it took me 12 steps to finish it. Okay, I just was looking at it again. I just got it in 7 steps. So I'm excited about that. I narrowed it down. I was talking to a student last period. He did some crazy stuff and got it in 4 steps. Okay, but he involved doing some different things. And sometimes your answer is perfectly good. It's just not very elegant. And that's perfectly okay. Work, try, fight through some stuff. And then also just realize sometimes you're going to get stuck. Okay, there's a time when you're going to look at a problem and be like, I just kind of lost it and I don't have much more for it. And that's okay too. Okay, so keep that in mind as we work through stuff today. Here we go. Establish the following identity. As you look at that thing, which side do you think is more complex? And that's okay no matter which side you pick. I'm going to pick the right. What about the right side makes it a little bit more complex? It's got tangent. And I don't really want to make sine become tangent. I'd rather make tangent become sine. All right, so that's going to be kind of my thought process here. This one has some elements of that 15-point problem. Not exactly the same, but it's got some elements that are the same. So let's adjust that side. All right. We are obviously trying to get to sine and cosine, so it'd probably be helpful to get stuff in terms of sine and cosine. So tangent, I'm going to rewrite that thing as sine over cosine. 1 minus sine squared over cosine squared. Everybody with me to this point? There's some different things you could do here. But let's talk about clearing a fraction real quick. Okay? If you took 1/2 divided by 3/4, and I told you to find the answer of 1/2 divided by 3/4, what would you do? Multiply by 4/3, right? We could multiply by the reciprocal. The answer is 4/6, or 2/3. Everybody agree with me on that? That is one way we could do that problem. There's something else we could do, which is called clearing the fraction. Okay? What I'm going to do is I look at this problem. I hate that this thing has a denominator in a denominator. That's terrible. Okay? So what I'm going to do is I'm going to multiply the whole denominator by 4. But I can't just multiply the denominator by 4, because if I do that, that changes the problem. So if I multiply the denominator by 4, what else do I have to do? We got to multiply the numerator by 4. Now we're good. We multiplied by 4 over 4. That didn't change my problem. Let's see how that works here. 1/2 times 4, what's that going to get me? 2. Those 2 4s would count. Oh, 2/3. Oh, yeah, same thing. Okay. Clearing the fraction, we multiplied by the denominator to get rid of it. Multiply the top and the bottom. Let's use that same idea over here. So as we look at this problem, I don't like it because it's got cosine squared in the denominator. I want to get rid of that. Anybody got an idea on how I could get rid of cosine squared? Multiply the top and bottom by cosine squared. Great. Now pay attention to that. I'm going to multiply the top by cosine squared. That's like cosine squared over 1. And I'm going to multiply the bottom by cosine squared. You can make it over 1 if you'd like to, but I'm multiplying the top and bottom. But that's not right. What I've done right there is not correct. Anybody got an idea what's wrong? Yeah, I got to multiply everything on bottom by cosine squared. So I also got to multiply this by cosine squared. Everybody with me so far? Let's see how that helped us. What's going to happen? Cosine squared times 1. Oh, that's cosine squared. Well, that's a good sign. Look at what our denominator is supposed to look like. What about this guy? What can I do? cancel. I got a cosine squared, a cosine squared. So it's going to be left with minus sine squared. Ooh, that's a good sign. That's what we're trying to work towards. Okay, on top, I've got sine over cosine times cosine squared. What can I do there? Cancel a cosine. It's cosine squared and cosine. I'm going to cancel one of those. I'm left with sine of theta times cosine of theta. That's a good sign. That's what we were trying to get to. Look, we're done. We got this side right here, and it's equal to that side right there. We win, QED. Did you do it that way? Probably not. Good. Wonderful. Anybody else solve it a different way? Great. What'd you do?
Okay, so I knew cosine and minus sine squared was -1.
Okay. Today, what we are going to do is some whiteboard practice and see how we are. So clear off your desks for me. If you got a whiteboard marker, pull it out. We'll get going. On your whiteboard, you are trying to solve that. When you get an answer, hold it up, work together, talk it out, see what you can get. Go. Let's look. Two ways of doing this problem, okay? And I would say most of you did it one way. Somebody did it the other way. I don't even know who I stole this from. There we go. I stole from there. There's two different ways to do it. The one thing you might see is 1 plus cotangent squared. You see 1, you see squared, you think of Pythagorean identities. What Pythagorean identity deals with 1 plus cotangent squared? That is cosecant squared. And doing that substitution makes this really easy because how are sine and cosecant related? They're reciprocals, and two reciprocals multiplied together is going to get you 1 equals 1. Done. Okay? That's all you had to do to that one. This was a little bit different. Here, they replaced cotangent squared with cosine squared over sine squared, and then they distributed, and then got sine squared plus cosine squared equals 1. That works as well. Okay, there's not just one way to do these problems. There's lots of different ways. Just depends on how your brain works. Questions on the first one. Flip with your neighbor, other person. You are now writing. A little bit longer this time. See what you can do. We look at this guy. First thing I notice, sine squared plus cosine squared. What is sine squared plus cosine squared going to get me? 1. That's a Pythagorean identity. And then it's minus sine u, cosecant u. How are those two things related? So they're going to cancel, get you 1. Okay? And then I got cotangent times tangent. How are those two things related? Reciprocal, so it gets me 1. And then these two things are reciprocal, so they get me 1. 1 minus 1 gets me 0, so it's 1 equals 1. Yeah. Good. Questions on that one? Flip it back. Other person's going. A little bit tougher. That was the easy one. Now we got a tougher one. See how you do. Let's see what we got. Which I'm good with you working with both sides. And this one I would specifically because you got tangent, you got everything. Secant, cosecant, a little bit of everything. This side would be a little bit easier. So maybe just transfer. The secant is the same thing as 1 over cosine. And cosecant would be 1 over sine. So that's what I'm trying to get to. Cosine x, sine x. If I do tangent first, tangent is sine over cosine. And cotangent is cosine over sine. I have two fractions that are being added. If you have two fractions that are trying to be added, what should you do? Common denominator. So this one needs a sine on top and bottom to match that guy. This guy needs a cosine on top and bottom to match that denominator. So my new denominator is going to be cosine x, sine x. Ooh, that looks good. Yeah, we like that. Sine times sine, sine squared. Cosine times cosine is cosine squared. Now what? Pythagorean identity. That is 1 over that guy. Oh no, that was a terrible idea. I was trying to super cheat and it was terrible. Cosine x, sine x. And that's going to be equal to, yeah, what we want it to be. 1 cosine x, sine x. Done. Questions on that one? Common denominators, helpful. Switch with your neighbor. Let's do it again. We start off on this thing. Again, I would say this is the easier side, cotangent x. We can go ahead and write what cotangent is. Cotangent is cosine over sine. But we probably want to mess with the more complicated side, the left-hand side. Okay, the first thing I would do as I look at this thing is I would realize that secant is 1 over cosine. And then that's times sine. So the sine is also on bottom. Okay, you could write 1 over cosine and do some different things. Just know that that cosine is going on bottom. Okay, so there's that so far. And then we've got minus sine x cosine x. We got two fractions. They're being multiplied by, or there's two fractions. I'm trying to add or subtract them. What should I do if I'm trying to add or subtract two fractions? Common denominators. This one's cosine sine. So this one needs to be cosine sine. So I'm going to multiply top and bottom by sine. So this is, bottom is cosine sine. The top is 1 minus sine squared. Anything we can do with 1 minus sine squared? Cosine squared. Pythagorean identity. 1 minus sine squared is cosine squared. Then what? Cancel out a cosine. I got 1 on top, 1 on bottom. I get cosine over sine is equal to cosine over sine, QED. My handwriting gets worse and worse as the day goes on. Good to there? Yes, ma'am. Yeah. So if I were a good teacher, I would always put them. If you notice earlier, I always put the x's in the thetas, but as I get tired, I quit putting them. They are important. They need to be there, but I understand that if in your work you don't put them. So, sure. I would say put them all the time, unless you forget. I'm not going to count it wrong. But they're always there no matter what. Try the next one. Easier way. So again, if you switched it to sine and cosine, that works. What about this problem would make me think, hey, maybe not switch to sine and cosine yet? Henry? Yeah, I got that secant squared there, and I got a lot of tangents in this problem. I know that tangent squared and secant squared are Pythagorean identity. Okay, so Henry said if I distribute this guy, I'm going to get tangent times cotangent. What is tangent times cotangent going to get me? 1, they're reciprocals. And then tangent times tangent is tangent squared. 1 plus tangent squared. That is a Pythagorean identity. 1 plus tangent squared is secant squared. Boom, they're equal. Done. One more. This was the hardest one we did first period. Don't forget about your best friend. Your best friend's name is Conjugates. See what you can do. Here we go. Again, there are different ways of solving this problem. If you go to terms of sine and cosine, it'll work perfectly well. You can get there. It might take you some time. Okay? There are different ways of doing it. It's just a matter of finding maybe the most elegant way. Again, as I look at this problem, I see secants and tangents, and that alone. So when I see secant and tangent, I'm thinking Pythagorean identity. And the one Pythagorean identity we got is 1 plus tangent squared equals secant squared. That is a Pythagorean identity we know. So that might help us later on. Did I talk about Mouska tools the other day in here? No, you guys not watching Mickey Mouse Clubhouse? That's a tool that we'll use later. All right, here we go. Oh, yeah, I watched a lot with my kids. Here we go. We are going to use conjugates, and the thing we're going to do here is multiply by secant plus tangent. That is the conjugate of secant minus tangent. And if we know how conjugates multiply together, what is the denominator going to be here? Secant squared, secant times secant, secant tangent, or secant squared. The middle parts are going to cancel, and I'm going to be left with tangent squared. On top, all I have left is secant v plus tangent v, and that looks like a pretty good top to have. Now, I wish I could do something with this secant squared minus tangent squared. Like, move this over. What could I make secant squared minus tangent squared become? 1. And so if this is 1, then I am left with secant V plus tangent V equals secant V times tangent V, or plus tangent V. Tombstone. It's weird. You might not have seen that. You might have done it completely different. You might have done sine and cosine. You could still get there. It's just going to take you more time. Getting your brain into some of those tips and tricks of figuring out what to do is going to help you out a lot as we go. Questions on something we did today? Here's what you